OK， 好，第一，这是我的名字，我是争取上课是用中文上的，可是呢，我数学上的词汇不够，所以肯定是写，而且我不会写中文，所以呢，我写的肯定是英文的，然后我需要你们帮我翻译，然后我希望从你们这里学一点中文。
我们自己会英文，我们自己
你最好是还是给我翻译，好吗？然后第二个事情是，我希望我们先做一轮自我介绍，你们最好把你的名字写到上面去，然后把拼音写上去，主要是我读不了，然后这样的话我可以记住你们的名字，好吗 ？OK， 先我自己自我介绍一下，我是 Lynn Heller， 我是3年前差不多2022年回中国的，是在武汉出生的，我是中国人。然后呢，我到8岁到德国，然后从到德国到搬到中国这30年，差不多就回中国2次，2个星期每次啊。所以我的中文是这2-3年才学的，所以不会写，可是读还是可以那么一点点的。所以他们给我发了个照片，写了你们的名字，可是呢，我实在是读不了，所以你们把拼音写上去，我会。然后这个课我们是上的是几何，我的 goal 是做 discrete differential geometry， discrete geometry。goal 呀，我们不能从这里开始，所以我们是一共上15个星期的课，15个星期，所以有差不多3个多月的时间，每个星期都是星期5，然后我希望上一共是上1个半小时，我会每次讲10分钟的课，让你们有10分钟小组做一点作业，然后再讲10分钟的课，这样子差不多做模式，好吗？这是我，然后呢，我希望你们自我介绍一下，主要是我想知道的是，第一，从哪儿来的 ？So from where? Hobbies. What else? Food. Okay. Video games.
Oh no, I hate video games.
Oh really?
Sorry.
Mangas. Whatever. Okay? Yeah, whatever you like.
Actually,
no
oh, by the way, what
漫画
does mangas means?
漫画 it means 漫
Whether you like it or not. Okay? 帮我每个人说一下名字，多大？哦 age, name and age. Yeah. Okay? 我想的话，你们差不多跟我小女儿一样大。我3个孩子，一个18、16和12，所以应该你跟我小女儿差不多一样的年龄。对，差不多，就这个。你们漫画，你们喜欢看漫画吗？
讨厌，非常讨厌，
非常讨厌，
我不喜欢
不喜欢。那喜欢什么其他东西也可以告诉我。
那个 video game，
啊
那个游戏也
He
不
likes
太
Desmos very much.
我不太喜欢游戏，但是很喜欢 Desmos。
哦，好的好的 ，OK， 从哪儿开始？从你这开始吧。然后可以写个就是 make a name tag for me。
Okay.
好 ，money please。拼音 ，yeah like this。
Okay.
Because that would be the first task. OK， 然后把你拼音写上去，写了。
可以，完全没有问题啊。
完全没有问题就好。然后我的手机在哪？在这。好，来面。加光眼 ，OK， 好的，加光眼。
Okay. So that's all
That's all right.
right.
4个字啊。
Yes. 老师要写拼音是吗？
啊，然后长网址闲。嗯。
Okay. Okay. And the
我觉得比起英文名，然后叫英文名。
也可以，
Yes.
也可以 Mia。
I have 2 English names.
那就 whatever.
Prince or Terrence.
Terrence, you want to?
Terrence 是啥？
Oh, Terrence Tao.
Yeah.
被我说了。
That's one of my English names. I have 2. Actually.
Okay.
高老师，您能不能讲简单一点？可能会听不懂。
没事，我们按照你们的。来。Okay, all ready?
You want us to make a
Name, yeah, like something like that. 于是同，就 make it that way that it stands. 就可以，就那个样子。
Yes, like that. Okay, I have
So
paper
good.
now. Can I just...
maybe this is very.
Oh, come on, you can fold it in a way that it stands on its own.
Look, that's just fold,
Go like this.
For parts and you just...
Fold.
Yeah,
It's-
fold it.
kind of.
Okay.
That's
这样子也可以。
对，肯定可以。
从那上面取。
这个奇怪的
Actually, I
可以
really
可以这样。
like geometric topology.
Okay, that's great. 记名，Jimmy, that's nice. Okay. 周俊明，李秉成，好的。谢啦，爱天宇 ，Eric. Okay, good. Perfect. Tony, 再开始吧。Name I know, Mia. 很好。我多大？今年12岁。And then from where? Which city? Huh?
Sydney.
You're from Sydney. Great. So I wanted everyone to draw it on the map, but then if it's Sydney, that makes it slightly more complicated. So, can you draw China for me on the blackboard?
什么？
把中国的
我
对画一下。Oh well, Sydney somewhere else, right?
我画，我不太会
Okay,
画。
Let him draw the map of China, and then maybe China there, and then we do Australia here.
like this.
Yes.
I'm not so good at that.
Great. Okay. Nice. Very good.
Okay.
And then you draw Sydney for me into his map.
我把你哪里去找呢？你确定不是？
Okay, that's Sydney.
那澳大利。
Okay. And that's Mia. Okay. And now, what are your hobbies?
I like doing sports,
What kind of sports?
swimming, running, and maybe dancing.
Dancing. Great. And what's your favorite food?
Pizza.
Pizza. Oh, I like pizza as well. Do you like video games? No, and no mangas. What else do you like? Do you like reading?
Yeah,
What kind of books?
maybe novel.
Favorite authors? Not really. Okay, great. Thank you, Mia. So, Ai Qianyu, Eric.
Okay.
Hunan, where's Hunan?
Hunan is let me think. Maybe here.
Okay, that's Hunan, you say?
我画 I'm bad at drawing.
That does. Okay. So, now, what's your age? How old are you?
Age.
That's a secret.
That's a secret, but
Yeah,
I
that's a
can
secret.
tell
Secret.
you.
It's a-
It's 11.
It's
It's a prime.
Okay, perfect. So now, what are your hobbies? What do you like to do?
Hobbies, I like reading books.
What kind of books?
Oh, the that's latex.
Analysis.
Analysis. Okay.
Analysis or some algebra.
Algebra. Non-math related books? Novels? Do you like No. Okay.
I don't
What-
like novels.
Okay. What about food? What's your favorite food? What do you like to eat?
My favorite food is noodle.
Noodle. What kind of noodles? Noodle soups.
云南米线。
云南米线.
I'm from Yunnan.
I see. I see. Great. So you don't like video games?
No.
No mangas.
No.
What I wanted to have, recommendations for video games and manga as well. So now you, where are you from?
I'm from Beijing, China.
Okay, can you draw it for me as well?
可以写我。
在那儿吗？
And now more like a chicken.
Okay, just write Beijing there.
快擦掉吧。
擦掉。
我要问你干嘛？
好的。
It's small.
It's small, very good. And what about what's your hobbies?
My hobby is I think also reading some books.
What kind of books? What do you do if you do something else than school?
Also reading.
Yes.
Analysis, great.
Really like analysis.
So what's your favorite food?
Maybe ice cream.
Ice cream. What kind of ice cream? Which flavor? Chocolate. Good. And video games, mangas, no recommendations for me? Really? Should I believe you then? Oh my goodness. Okay, good. So it's stone you?
Yes.
丝桐。
是
Okay.
丝桐。
丝桐. Oh, I see. Perfect. Okay.
Okay, and
Terence.
really far from from Beijing. I'm from Yunnan province.
Yunnan. Okay. Pretty. Kunming.
Yeah.
I see. That's one of the very few cities I know in China.
I'm from Kunming, and my name is Changwang Zixie. And then
Okay, 长王指
and my hobbies, I think I really like math.
Well, something else, non-math.
Um,
Non-math hobbies, please.
Music,
Music, what kind of music?
art, and that's classical music.
Classical music. Which?
Especially the ones by Bach.
Who?
巴赫。
Bach. Okay. Perfect.
And because he's a German, I don't know how to
Yeah,
pronounce his name.
that's
And
it.
food,
What's your favorite food?
my favorite food.
Yeah.
Maybe rice noodle.
Rice noodles, soup, right? It's noodle soup.
Yes, maybe.
Okay.
And I hate video games, and I don't really like mangas too.
What a pity. Okay. Now, Jimmy.
Yes.
So where are you from?
I'm from Liaoning.
Can you draw it on the map?
那我回答能拿中文回答吗？
当然可以。可以用中文回答呀。想说什么就说什么。Okay. What's your hobbies?
My hobby is sports like basketball,
Basketball.
football,
Okay.
or skates.
Skates.
And I also like music.
What kind of music?
和长子欣一样，也可以。
Classic music. Great. Do you play instrument?
No.
No.
Because I often study math, so I
Have no time.
yes.
No time? Oh, okay. Good. What is? No video games. No. No. You don't want to say it?
No
Okay.
video
No.
games.
Okay. No mangas. Okay. Good.
你随便说一个。
周俊明从哪来的？
中餐
河北，应该就在北京附近。你帮我画一下。河北。
背死。
这鸡画的好。What are your hobbies? Oh, I forgot to ask. You are all 12? No, 11, 10? You're 10? Great. What are your hobbies? non-math，用中文回答也可以。
用中文回答也可以。
恶作剧也算哦。
啊？
恶作剧也算。恶作剧也算。
可信不要。就是这名字的机关枪出现。
非得要把那玩意儿擦了。就是。That's really funny.
Okay, what about food? What's your favorite food? 最喜欢吃什么？
I don't know.
也不知道。
Rice noodle.
Rice noodles 啊，都喜欢吃面条啊。好的。Okay, anything else? Video games, mangas, no?
Decimals.
Decimals. Okay. 我得查一查。
那个属于。
I need to check it what it is.
A little bit like video games, but a mathematical video game.
I think I know.
一个数学型计算器。
反正也可以编一些的。
Oh, good.
无形计算器。
Perfect.
You can use mathematical methods to give some.
You didn't say anything about decimals. Okay, what's your name? 李凌晨。
丽丽。
厉凌晨啊？这写的是
哦。
Too small.
啥？我看。
写的
你怎么标3声啊？
你写的是三声呢？是厉吗？
你好聪明啊！
好吧。
李。
哎，How is it in Chinese?
Lee
You're good in Chinese, yeah? Okay, perfect.
Lee algebra.
写错了。那 Okay. So you are 12?
Lee algebra.
Yes. Hobbies.
I like play piano and play football.
Football. Great. My whole family plays football. So what about favorite food? You all like carbs. You all like noodles or pizza. No one likes rice.
Maybe I don't know.
You don't know. You never try. Okay. Video games? No video games. No. Oh my goodness. Now you. Oh, I forgot to ask where you're from. Can you draw it for me? Jiangsu. I see.
That's the name of province. Just like
Okay. Now you.
我是。
贾广言。好
我也
的。
是出生于北京。
北京。Hobbies?
Hobby reading.
读什么？
Reading novels.
啊
Reading novels.
？Which one?
Novels。
什么？是作者
什么都看吧。
什么都看。什么样的故事呢？Sci-fi, romance, fantasy， 都看吗？什么都看。
反正是。然后food什么都爱吃。
啥？都行。
你随和，好随和哦。
只喜欢中餐、日料、韩国的面食都可以。你们都喜欢吃面食是吧？都不喜欢吃米饭。差不多。喜欢吃面食。好的。
被101训练出来。
No video games, no mangas.
可能看过，原来小时候看过。
小时候看过。好
I
的
think。you also like video games.
你不喜欢吗？
喜欢。
不喜欢。好的，那我就把这个切掉。都不喜欢，那就好吧。有点不相信哦。Okay. Thank you so much. If you have any questions about me, I can answer these as well. Okay. If you have any questions about me, you can ask. Okay? So let's turn to math. So the idea again, 我们想做的是 discrete differential geometry. Differential geometry 是微分几何。我现在不是特别清楚 discrete 中文叫什么啊？离散。为什么呢？So first things, let me ask 2 questions. 第一，你们每个人写下来啊。我有。因为我想知道的是你们想学什么。
Okay, that's brilliant.
Okay. 第一 ，What do you know?
think I will write them. So
所以今天没有多少内容啊，只是先想看看你们到底是知道什么。OK， 你们想知道什么？然后第三个是为什么这个几何重要？Important, well, I guess, important applications 有什么应用的 ？OK, applications. OK. Okay, these four. Just name 3 or something. 3 things you want to know, 3 things you want to know, 3 applications, and maybe 3 prerequisites you think you need to know. Okay? Okay, I give you 2 minutes, and then let's talk about it. You just write it down, please, for me. Doesn't matter. 你用中文用英文都可以，想写什么就写什么。你读给我听就行了呀。是吧？Let's take a picture. 哎。
老师，如果什么都不知道该怎么办？
就说什么都不知道。那你给我说一下，对你来说几何是什么？是做什么的？几何是什么意思？也可以。什么是几何？你觉得应该什么是应该是几何？
图形。
那写啊。 No, don't look at the others' answers. Okay, can you
Okay.
just come forward?
Okay.
Let me just say.
Um,
And again, we collect those here.
okay. And
1, 2, 3,
the
4. Just write
the
down.
first one and okay. I know a lot. I know differential geometry and I just proven Stokes theory by myself.
Okay, can you write down?
Okay.
Just no, not just differential geometry.
Okay.
Okay, or Stokes theorem rather. It's not differential geometry, right?
Then, yeah, okay.
Just write Stokes theorem. Just write Stokes theorem.
Okay. Okay. Like that, and I think I'm good at geometric topology.
Where are you? Okay, yeah, geometric. What is geometric topology for you?
I think this is like you see manifold in the view of topology.
Yeah, but what do you want to do with this? What people do in geometric topology?
It's like they found that how about just like found out maybe how does the manifold change from one to another and this and then there are homomorphisms to each other and
Okay.
like this
Okay.
and this, let's say maybe a little bit just a little bit of algebraic geometry.
Okay. What is algebraic geometry for you?
It's
These are huge fields, yeah.
Yeah,
all of
it's a
them.
huge field, and I think that's really hard. And
What kind of algebraic geometry do you know?
Maybe just some trivial definitions.
What kind of definitions?
Just like just a bit. I just saw just a few papers of the GTM 52.
Okay.
And
Write it down.
maybe
Write it
just-
down. GTM.
Just a little bit. Just a little bit.
Okay, that's fine.
And I think I just have to be I'm not stupid at it. And I think algebraic topology, algebraic geometry is just like a study that in which you just study and use algebra and to study what geometries do, and or maybe you study algebra using what you study geometry use what the people that are good at algebra do, and that's just like a connection of algebra and geometry.
Okay.
Okay, and
So what do you want to know?
I really want to know. I really want to know more about geometric topology, and I'm also happy.
Can you write it down?
Okay. Geometry. And I also want to learn more about algebraic geometry.
We will talk about it later. 待会儿再说。
And also, I think maybe symplectic geometry, but I think that's too hard for me.
Well, symplectic geometry is a lot easier than algebraic geometry in some sense, but okay. 再说。我们待会儿再说。
Can I just write down
Yes.
Chinese into the
Yes, if you want to.
Because someone really don't know what this means. And that's 几何拓扑. And GTM is a series of book for just like maybe yes, that's like that. And it's a bit hard. And
This is already there.
And algebraic geometry is yes.
再说几何。
And symplectic geometry, that means 新几何. And 3, what geometry? Why is geometry important and complicated?
Applications, yeah.
I just think that the most one that geometry that exists and really good in math field is that because that is beautiful. I think maybe most of the
Yes.
because it's really beautiful and maybe it has a really complication, just like Riemann geometry, and really has so much applications to to physics.
Okay, applications to physics.
Yes.
And what about something you do actually every day? Application to something you do every day? Have you thought about geometric applications to something you see every day? Outside world.
I think there's many.
What kind?
And maybe I don't know.
Okay.
I'm not so
No.
interested in applications actually. And for what you think, you need to know. I think if you want to just have a good geometry, you usually know many definitions, but also the institution behind it.
Okay.
And just like the main things that geometry maybe in the just lower just a bit geometry from just easy to learn, and that's totally actually is manifold, I think. Manifold, and that's the main one that geometry do. And the main
It's not quite true, but okay.
I don't know. Because
Yeah, it's fine.
I don't know
No,
so
it's
much about geometry. Okay, and
That's fine. Okay, good. Next one.
I think
No, everyone will. 每个人都可以，每个人都要。Come on.
one.
知道是 What do you know? Shall I write for you?
No.
有站到凳子上也可以。
You need to write this.
Yes.
One. Geometry has many fields.
oh, but you cannot just
Many fields. Let me. I can write. Oh, that's good.
And the second, geometry studies properties of shapes.
Yes.
Shapes. And the third one is Stokes' theorem is important.
Okay, we have Stokes' theorem already. Good.
And I want to know what is a manifold? Two, what is the goal of algebraic geometry?
Okay, let me write manifold
You
here.
have it.
Yes.
Okay.
Just manifold. Just write manifold. Perfect. Great. And what is why is geometry important, and why do you need what kind of applications can you think about? Don't know. Okay. And what do you think you need to know?
What do you think I need to know? First, some important definitions, like something about a manifold or.
Yeah, well, you want to learn manifold, so if you know manifold already, it's.
And I need to know something. I need to know some important definitions and important theorems.
Okay. Good. Next one. Do you want to? Thank you. John. So first,
There are shapes.
shapes. We're going to have shapes.
We can know about like the area.
Area.
So that's it for that one. And then for the second question, I want to know about like more than shapes.
More than shapes.
And then what cool things you can do with the shapes and stuff. And I also want to learn definitions for the equations.
You want that in 4? Or just learn definition of the equations?
And for the third one, You can use it in real life.
Yes, and what kind of use?
Like maybe pretend if you're making a house or like
Architecture.
Like
Oh my goodness. Architecture.
and they're a nice pattern.
Patterns.
Maybe drawing shapes together.
Mm.
And then I want to, for the fourth one, I just want to learn more about geometry.
Okay. Good. Just geometry. Okay. Perfect. Next one.
Okay.
Anything new to add? I want to. Okay. 为什么我写这个的原因？我想待会儿照个相，然后呢，我们是4个月以后再看一下，你们想学的学到了没有？第一，你们想法改变了没有？第二
I'm really hard to.
，Oh well, we will see. But probably you change your mind actually after 4 months, right? 写中文吧。
I can translate yours into English.
Yeah, just write whatever.
复根几何。
啊
It means that this was
Elementary geometry.
junior
Yes.
high, like that. And
That's fine.
补一下乙方。
然后
Yeah, just write it down.
you just write that.
Just write it down.
Just like classical differential geometry.
Okay, that's fine.
That's a bit.
这出的几何？
不是。
我好别的。
Classical differential geometry is not that. I mean, that one should be triangles, right?
I read that for you.
Okay. 都是 yes.
这高中学那些吗？不是，那古典微分几何没学过吗？
不是你不在看那一套书，我那套书就是古典微分。
You know better what he knows? Great.
哦，
好吧。
那就是对于函数一定跟三度一起。
That's okay. That's okay. It's okay.
真没学过。
好吧，没学过就差了吧。
好像别
你好谦虚。
我看你字底下的谦虚。
骂人。
这个一好像就没啥了。
啊，2呢？
说过了。
你想说过了也可以，就加嘛，只有机械还要加的。
然后这个就是好像这玩意儿也说过了。
Okay, that's fine.
And maybe this, it can make everyone choose one thing. I think. I think it can make.
Okay.
And I think we need to know the definition.
Okay.
What do you think?
Just def is fine. Def. Def. Okay, perfect.
Oh, okay. High dimensional space.
你拿中文写啊？
对啊。
有道理。
你拿中文写不
Yeah. 说中文是可以的，我听得懂，我读不了，有可能。你读出来了以后，我也学这个字儿啊。
为什么要
写英文更好吧？还是写
那我就说吧，
一样的。
就是首先得明确这个高维空间的定义，然后其次得养成高维空间中的，就是在高维空间中思考的几何直观与思维习惯，就是这个 institution。
嗯，好的。
不然就是这个
Intuition。
什么 institution 是学院？
Okay. Now you. What do you know?
I know some 初等几何，
嗯
然后一些关于一些关于一些关于图形的一些知识。
什么
图形 shape。
？OK， 什么图形？
就是基本上就是除了高维的，基本上都知道。
嗯，好的。
然后我还知道一些几何图，就是一点点。
可以。
A little。
OK。
然后第二部分就是我想知道manifold and
OK。
代数几何。
代数几何。
袋鼠几何 ？That means kangaroo geometry.
We can, you know, there is kangaroo geometry. I mean, there's.
你写中文啊？
对啊，写中文呢，真是的。
第三个我觉得。
Our professor cannot understand.
No, I can read, cannot read. 你给我读给我听的话，我是差不多是猜得出来的。
Geometry 是几何中一个重要的分支，然后我觉得就是有很多人会学，
那为什么你想学呢？
我觉得就是这个和它在生活中很有用。比如说，我觉得建模会需要它。建一些模型。
modeling, OK。
就比如说我们电脑里头就有很多就关于
对。
然后第四个，我想知道就是几何，就是几何和其他数学之间的一些关系。有什么关系？人生几何。
因为能够加个人生几何，我觉得也可以。
不要。
这可是我觉得我微信上的设定，这很要。人生几何很要。对，必须得要。
就是几何和其他数学分支的。
好的。
连是啥？
少了个字儿。好的。
哎，等会儿。
下一个。你写中文，没事儿。
你先下去。
你应该先写原始。
不是你能不能不要钻出？
为什么不能？
你还在这种地上该滚儿，好吧？
不要做那个。哎，就是写个人生几何。
人生几何。
这是不是那个李奥先生写的那本我的？
第一个也就是。
人生。好的。
中国传统的诗。
啊，就是第一个就是还是这个初等几何。
初等几何是哪？你们初等几何是哪里学的？高中学的。好的。初高中学。好的。
然后第二个就是摄影几何，然后
什么？
摄影几何不知道。
摄影几何是啥？
摄影几何
不知道怎么记得。
你写，用中文写。
摄影几何 ，it's just like maybe you studied in junior high or senior.
Oh, projective geometry. I see. Yeah. Projective geometry. That's projective geometry. Okay. 好的，可以。
你有想问到我？
好，第三个就是那个，就是设计一些东西的模型。就是感觉跟建模差不多。
差不多。好。第四个呢？
然后第四个，我觉得我写跟这个一样。
好的。Your turn。比给他一下。比给他。知道什么？
第一个话，我觉得我也只学了初等几何。
好的。
然后呢，第二个，我觉得我就是小学就是一些比较先学一些比较基础的，然后整个几何它最基础的东西。然后呢，第三个话，我觉得就是说培养出来的就是学几何培养出来的几何直观，可能现实生活中是有用的。然后第四就是说，就是几何它整体的框架。
好的。 好的，你来吧。
然后我也是学过初等几何。然后我想学的那个几何的话，就是最基础的那种高的几何，反正就是没有接触过那种高的几何。
好的。
然后我觉得那个学习几何重要，是因为它应该是另外一种逻辑那个思想，另外一种思想，就是跟代数不太一样的样子。然后
写下来一下，这个是新的，用中文写。
或者是。然后第4个就是一些新的几何知识。
好吧。
不知道。
这不知道。好的。So let me take a picture of all of this, and then let's review the thing in 4 months. Perfect. Okay. So now, 你们说了你们知道什么，然后我们现在看看你们到底知道什么。More details, okay? Because you never know. No, I don't write tests.
Yes.
It's a fun class, okay? No tests.
Wait, no. Wait, I just wait for this class. Go 10 years.
这都不是英文。我怎么知道你意思？还是
不是考试，只是问一下你们知道。Okay. So first, tell me what are these numbers, okay? With
Real number.
yes, but what is it? How is it defined? How is it defined? Definition. Wait, let me just write everything and then you tell me the correct definition.
Oh, that's really easy.
Yes.
Okay, I'll write it.
Perfect. Just
Okay, that's easy. That's easy.
okay.
Real numbers. Real numbers definition is all. Okay, I should.
I want the definition. No, I don't want the name. I want the definition.
Definition. R is the limit. Okay. R is.
Okay. Just to be sure, just start with. Maybe you should start with n.
Okay.
In this case.
Is that from piano accent? Okay.
Piano with e. Not piano. We don't play piano. We have a piano axioms.
Piano. The first one. How do that? Zero. It exists. Zero in n. Yes. And for all n. N plus. That's the notation from Terence Tao analysis.
Well, you want n plus 1. You want not 1. You don't want 1. Okay.
Oh, it's just like.
Well, you can do.
Yeah,
That's fine.
We haven't defined one.
You can.
Yes.
Okay.
And 3. That for n in n and for n. Okay, and there's no n such that n plus equals 0.
Okay.
Okay, and the fourth one. Yes, if n plus plus equals n plus plus, if and only if n equals n. And the fifth, i.e. that just like suppose the pn is just it is okay. It is
Induction.
It's induction.
Induction
And
law.
for P and the how to say what
归纳法。
命题? Oh, I just
PN proposition.
yes, and if first one P0 consists, and the second one if Pn consists, then Pn plus consists for all n in the natural numbers. Then Px consists for all x in n.
Okay.
Another version is if a set S such that if a set S satisfies the two conditions. The first is 0 is in S, and the second is if n is in S, then n plus plus is in S. And
Okay.
then we can deduce that the set is the natural number. The set
Okay.
is natural number n.
And okay, perfect. So I will not ask what 0 is, but okay. What is Z? And then
Okay,
no,
what
next
Z?
one, next one, next one.
Okay.
Because he wants really to answer ask question as well.
后 C 已经准备好，下一
Good.
个是 Z 吧？下一
嗯，
个是 Z。
对。
You can just
Z。
只有科系有理训练的形式体现出来。
It does.
I is a relation.
Mm-hmm.
Okay.
Z the set Z, the integer number is the integers is n squared.
Mm-hmm.
Is all equivalent classes of
Mhm.
是 I 的等价类。
用中文说是可以的。
Where I 其中 A B 与 C D 有 I 关系，等价于A加 D is equivalent.
Yeah.
It is equivalent to A plus D equals B plus C.
Mm-hmm.
Yeah.
Okay.
Q.
Q. Next one.
It's just like a race.
Q。
Yes.
找了个好点的地儿啊。风水界。We say X is the element of Q. 钢铁子。
Oh no, that's just no.
Oh.
It's not yet geometry. But we need a little bit of analysis before doing geometry, right? Mm-hmm. All right. Would need to define that one, but okay.
No, actually.
看起来不太严格的
Because
样子。
You need to define.
看起来
Yeah, you didn't define the division.
Yeah.
有没有定义除法？
Okay.
除法
I
是
think you can just write
看起
down.
来不太严格的样子。
拿中文去，
啥叫除法？
拿中文。
不知道。Q 是 Z times
录音
Z
中文。
除去下一个。We will
说中文，说中文。
我们用 J。We will denote this J. J A B C D is equivalent to A D equals B C. Oh.
Well.
That means that means all integer except 0.
Yeah.
Okay.
整数除去0。
Okay.
整 整数排掉0在外。
Okay.
Okay.
好了，
Next. No. Do you know you
He cannot.
you don't want?
Okay.
You?
I know.
No. What is R?
Only. Okay.
And then what is C?
Okay.
So do you know what R is? 你知道吗？
Um,
你有这方面的知识还是没有这方面的？
information.
学过但忘了，
A
忘了。
lot of information. First,
所以能不能让他拿中文讲？
For example, we give okay. Let us give a norm in Q and
我们需要
Q square.
他讲的是完备化，在
Yes.
做完备化。
Okay. This is the definition of analysis or functional analysis.
I don't care. Just write one.
Okay,
Right.
just give norm from Q2 into R
但是第三
bigger than
那个
0.
叫
Okay, that is a norm. That's a norm.
you didn't define what is R greater or equal than.
Oh, yes.
Well, That's why. So you don't.
Tut mir leid, was habe
Oh.
ich nicht verstanden?
Yeah, that's what my theory. Lovely.
Q square to Q bigger than 1. Because that's not. And it's like you give the pairs X over Y, Z over W into.
没定义除法吗？定义了，
定义了呀
也可以有了。
常子能拿中文讲吗？
Y minus Z.
用中文讲，用中文讲。他们都忘了。
我们首先给一个映射，它将 Q 方映到 Q 大于0。这个绝对值指的就是，如果它是以0的话，那就取0；如果它是正数，那就取正数；如果取负数，那就取它的相反数。然后这样这个意思就是说，我把 x 除以 y，z 除以 w， 然后把它映到 x 除以 y 减去 z 除以 w。然后呢，我们说，然后我们现在定义一个集合它的长度，一个集合它的半径，如果欧米伽是一个小于等于 q 的，那么我们把它定义为现在定义对，其实可以这么定义，sub of x y in v。
嘿，有 sub 吗
？sub 还没定义呢，sub 还没定义呢。
需要给出的。
No. Just write it down, please. I mean, just you can just say it actually just as a completion. That's fine.
没有 yes.
Just as a completion.
Okay. I think you can just think like this.
sub 也可以。
Limit is not defined now.
Well, doesn't matter. For now, it doesn't matter. You had it already. Okay. Just say that R is the real numbers, right? And
R is the real numbers.
So, and what is-
functional analysis? You can just think R is the minimum space of of that norm and
yes.
and the
Okay, just-
the complement
Oh,
of
can we
that
just write Q? I mean, just since I'm not interested in other completions, I just did write this one.
Okay.
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 And C.
C.
C R
R plus
一个数。
yes. X
R 乘 R
Y square root of 1 and we just write this as
Okay.
where X and Y is in is in R and actually
Yeah.
C is a 代数比喻
is algebraic closed.
Mm-hmm.
Is algebraic closed.
Yes. Well, you can maybe. I prefer to write it as 2. Okay.
Yes, yes, that's a really good method from C to R2.
Yes. So why I'm writing this? Okay. First of all, I want to use it.
Yeah.
Okay. So you need to know what it is. But second, we want to do first plane geometry. Okay. 我们做 plane geometry from axioms, and we need that for later because we want to do discrete and then differential geometry. Before we can start with differential geometry, we would like to understand what discrete means. Okay?
Yeah.
So this is now our plane. Our plane
Yes.
where we work. Okay? 2D. Okay? So now we want to consider it as complex numbers or R2. Okay?
Okay.
Everyone know what that is?
Yeah.
Sure?
Yes.
Sure?
Yes.
Those you said already, so I know, but these who are silent, you know what it is? R2?
So I think someone don't know.
You know what R2
可
is?
能有人不
I
知
don't
道。
know. I don't want to speak.
I mean, we are 7. So it's really important that every single one of you know what I'm talking about.
加光也
Yeah? 每个人都需要知道我在说什么。
你知道了吗？
Yes. 知道这是 R2 是什么吗？
知道 R 吗？
Yes. 知道。知道。It's okay to say no. I explain. No? No. Okay, what is R2? R2 is our plane. So like my backboard. Okay?
Just saying that two-dimensional you can explain.
是 R 和 R 做直合。
Wait a sec. Okay?
直击。
And you would have coordinates, right? You would say R2.
Explain why plane.
Wait a sec. You would have a 0 somewhat.
Yeah.
And because this thing is your 0, so you would be 0, 0. Right? And then you have one direction, which is your x direction. Okay? Or some other letter, whatever. Yeah? Klaus. What? Instead of x, I can call it Klaus. Why not? In the other direction, normally you can call it y, I call it Moritz, which, because these are nice German names. Okay? Why not? Okay? And then I can say, well, I can give nice coordinates of any point in my plane with respect to my 0, right? So 1, 2, 3. And here, for example, I have 1, 1. Here I have 2, 2. And of course, you can have any other numbers like 0.5, 1, and so on. Okay, that's my plane. This is what I want to do geometry with. Because I want to give you points on the plane, and I want you to draw a pattern. Okay? Okay? Well, that you know is fine. Everyone else needs to know as well. Okay? Next. What is a line? What is a line?
No. I think in maybe one-dimensional, one-dimensional medical.
哎，不是
No.
不是，那是这个可以是弯的，
Okay,
说
then
的
it's
可以
like
是
a
弯
line.
的。那个 line 是不是一个圆一次方程组的点集？能这么说吗？可以。
Well, what is a line? So normally it's we would want lines to be straight. We don't want it to be curved. 直的，
直的两边平行线。
right? Well, that's not quite straight, but okay. Right? So that's a line. But how would you define it?
Define
Okay,
it as,
there's many.
can define it as the set of solutions.
Something that connects to dots.
Yes,
两个点的线，
exactly. So
两个点的。
if I have 2 dots, then I would have a line connected. Well, and then I have
欧几得是也可以。
this one would be a segment, right? Because it would end here and there. Segment. If it goes to this one and start at A and goes on this one side infinitely, that would be a ray. From A to B, yeah? And if it goes on both sides indefinitely, it will be a line. Okay? I should write it as capital R because small r is normally a radius. Okay? Okay, so you know. Good, that's easy. Then I need to know sine and cosine, you know. Yeah. Okay, perfect. R2, you know. What are isometries of R2?
Isometries.
Yes, what does it mean? Isometries of R2.
平移下去了之后可以
Isometries
可以
就是宝
重合之后的
距变化，对，宝距的。
就是经过宝距这样变化。
平移旋转，平移旋转，
As a orbital in the Banach space.
平移旋转。
Exactly.
Yeah.
Okay. Rotations. 反射是reflections, right?
加起来。
and
And
translations.
translation.
Okay, I move a point like this, I rotate, and I reflect. That's all. Okay, good. Next. Because we need to do differential at some point, I need to know what is a differential.
Okay, I think they are really tough. They know a lot about it. I think you can.
What is that?
We can
In one variable,
You
two.
just only need to think there's like function and the local. And this, yeah, like this locally, and it's like the rational.
So what? So, do you know what that is? 中文是什么我都不知道。就叫微分吗？
微分。
好。那how to compute tangent of a circle? Just compute it, please.
compute tangent of circle.
Yeah.
圆的切线。
So first of all, you need to write down a circle.
圆。先得有圆。
Yeah, and then you compute the tangent of that circle.
函数求导的。
I would like to have the equations for this. And I want to have an equation for the circle. Yes. Everyone can do that. Everyone should do that for yourself. Just because you say it's easy. Explicit equation with numbers, please. the more normally, things that are abstract are far easier than explicit. Yeah? Good or not good? We will see. So what would your equation of the circle be to start with?
X minus a squared plus y minus b squared equals r squared.
Okay.
Okay.
Now?
The tangents that pass through x0, y0.
Well, that's S. Yeah?
Is y0 minus b y0 minus b times y equals a minus x0 times x minus x0.
What?
X minus x0.
Wait a sec. Does it? Well, it's 2 times. There's some y that's there. Where's?
Okay. And there's something. 还有一点没说完。
Okay, just say.
M plus y0.
Yes.
There's. Okay. Good. What about if it's 0? Then it is x equals 0, y equals 0. It should be x0 and y0. Is that correct? Yeah, I can't see it from here. Yeah? How do you compute it? How do you compute it? Explain. Can you explain?
Oh, no.
Yes.
Okay. We need a.
Is that even correct?
还有一点。忘记了。y0 times y0 minus b. That is.
I think it's this way. Yeah. That's all right.
Okay.
And then it's not a line yet in the sense that, okay, well, I think we can do it. Is that okay?
I hope.
I think there are 3.
There's no norms. Yeah, lots of ways, yeah.
Calculated. One is using like what he said, and one is using like that. This one and this parallel.
Perpendicular?
Perpendicular.
Yes.
And
Probably,
line and-
yes.
And this the scalar of this
So the easiest way probably is just that the
theta is not equal to 0 or pi, then this the slope of this is just negative cosine of theta.
okay. So the easiest one is actually to take this and say it's perpendicular. But the problem with this is you would need a scalar product, right?
Yeah.
You know what a scalar product is, all of you? Okay, perfect.
数量级
And another one is just because the circle is just the
implicit differentiation.
or just you can write down that the circle is just like y equals positive or negative square root of 1 minus x squared.
Yeah.
And you can just differentiate.
What's wrong? Is all good? Yours? Okay. Yeah, it's getting late. Okay, good. Perfect. Roughly that's... So now, next one. What is S2? Ever heard about it?
So yes. S2.
And I would like to know what is H2.
Oh, yes. S2 is what we call that. S2 is maybe SH.
What? 2. Come on.
And
If you can
you
define...
just, give it a matter into R3 and just give it that X, Y, Z in R3. Such that X squared plus Y squared plus Z squared equals 1.
Good. Draw S2.
Yes, that's like this. It has 3 coordinates.
所以你再画一个，可能好一点。
Okay, it's just a ball, yeah?
Yeah, the surface of the ball.
Well, yeah, it's the surface of the ball. Yeah.
Exactly 1, not
Yeah.
2 parts. That's right.
Yeah. Okay, what is H2?
H2
Anyone knows what H2 is?
Um,
Huh?
a torus or
No, it's not torus.
No?
Well, what is H2?
It's fine. It's not.
You
But
know that,
it's hyperbolic space.
Yeah.
So you don't know. Okay, perfect. Good.
Okay, so is that
That's fine. I just want to know what you know and what you don't know.
is that up to 2?
No.
Okay. Oh, I have heard that. But I don't know.
You don't know what it is. Okay. Good. The next one. What is a vector space versus and what is the difference between a vector space and an affine space? What is the difference? Do you know?
A vector space satisfies 8 axioms about the scalar products and addition.
Okay. Good. What is the difference between vector space? So you have learned that somehow at some point. Okay. You know, learned vector spaces here?
Yeah.
No? Yes? Kind of? I don't.
向量空间，对啊，我们修现代数啊，
有点道理。
Great. What is the affine space though?
有道理。
空间
What is the difference between a vector space and an affine space? Anyone know?
是仿射空间吗？
应该是。No, 放射。affine.
仿射，那都反射，那都仿射。
Okay, it should be, yeah. It should be the right one, yeah. 应该是的。 Okay. Do you know the difference?
It doesn't have to pass the origin.
It has no origin. Yeah. No. So this one has a 0.
Has a 0.
No
but
0.
No.
So no point that is special. Okay? It has one point that is special, a vector space. And so for geometry, why is it important to distinguish? Because we have here points. Right? In your plane.
Yeah.
And for the point, it doesn't matter where 0 is. right? But we have directions. And for those, it does make sense to have 0. Yeah? So we have your vector. There's a difference between 2 points. For those, it makes sense to have a 0. For the point itself, it doesn't make sense to have zeros.
Yeah.
So difference of points is a direction. Okay? And so it's really important to distinguish a vector space from an affine space if you do geometry. Yeah? Okay. Although it looks quite alike. We do R2. Yeah? We just do plain geometry for now. Good. So next, I have still 10 minutes, and I would like to...
Oh, by the way, I'd like we all like to listen to the class maybe longer.
Oh, we can have longer, but I think it's fine. But I would like to first know what you know before going to too much class, okay?
Okay.
Let me ask you, what do you know about Euclid's axioms for geometry?
Oh, okay. I know.
Or rather, plain geometry. We only do 2D for now. What do you know? What do you think should be an axiom for plain geometry? Hmm? 再说一次。
做直线外一点，只能做出来一条也只能做一条与其平行的。
Write it down, please.
这条我印象最深刻。
Maybe in English.
No. Chinese is fine. Just write it down first.
多直线歪。
写拼音去了。Mike. Don't do that.
你上来写。
Okay. So that's a parallel axiom, right? Axiom. So if you have a line and a point, then there exists one line exactly that's parallel to the given line. Okay? Good. What else? All right angles are the same. What else? We have 5, yeah? 2 you have. 3 is missing.
F2 things are equal. 不是，若 A 等于 B, if A equals to B, B equals to C, then
What is A, B, and C?
那不是这个不是等价关系的传递。
传递性。
Yeah, but for what?
不是几何。
所有的
Well, we start with easier ones. Mia said before, right? First of all, 2 points are connected by a line, and then and then we need any line segment or line segment can be extended indefinitely. Yes. And then we have lines. What we need, what else we need for geometry except for lines? We have one angle already. Sorry, one angle we have. What else do we need? Circles. Right? A circle. Very drawn. At any point with given radius. Okay. That's 5. The problem, what is the problem with this definition? What is the problem with these axioms?
The problem, yes, is how about two parallel? How about two parallel? This 它是啥的？
就是它是在 R 的 n 次方里面能生效的。
But right now it's true. But the problem is, first of all, what are angles? Right? What are points? What are segments? What are lines? And what is a circle? Right? It's not defined. Okay?
这个 circle 不是容易比较容易。
Well, then you just need distance. I mean, then you need a radius.
Yes. Yeah. That's actually no.
Okay? So where do you start? It's a problem. Okay. So Euclid did that 2,000 years ago. Okay?
Yes.
And, well, I guess until this one was discovered 1835 or something.
Yes.
Right?
Yes. Just like that.
That was that. And this is probably earlier since we live on the earth after all. Yeah. Okay.
So what is the definition of H2? I just forgot it.
Well, you can, if you want to define it, you can take, do you know metric?
Yes, of course.
Okay. You take upper half plane. Well, but remind me metric.
Oh yes.
The simple answer is that one, and then the other one is the upper half plane.
Oh, I know. I get it.
Oh, and then the G is 1 over y squared scalar product.
Oh, I get it. Oh, okay.
Well,
I get it.
later.
Later.
We do it later. But this is for him. Just okay. So before we do that, I would like to do proper geometry, starting with what it means. Yeah? So that's maybe the thing I want to do today. And then next time, I would like to start with curves and a bit of differential geometry, because we need that one for later for the discrete part of the geometry.
Yeah, that's true.
Okay. So this is Euclid, which is incomplete, but basically these are the axioms we needed. Okay. And then Hilbert came. I prefer Hilbert to Tarski, but okay. And he said we have first primitive notions, meaning things we don't define. Okay? Which, well, are these. So let's say actually only 3 points, lines, and plane.
Yeah.
Okay, so, well, actually only one plane. We just want to do plane geometry. And then we need, these are objects, okay, of my geometry. And then I want to have primitive relations. So these are betweenness. The second is containment. Something is contained in something else. And the third is congruence. Congruence. Okay? Betweenness is I have A and B, I have the line. I would like to know what it means for a point to be in between A and B. Okay? Containment means if I have a point C, I have a circle or something, I would like to say when is C inside, like on the circle.
Yes.
And third is I have triangles. When are these, oh my goodness, triangles the same?
Yeah.
Up to Euclidean isometries. Okay? Though I haven't defined it, what the isometry is yet now, but it's just for you, for the words, okay? So we have three things, points, lines, and a plane. And then we want to define all these other things, triangles, whatever, with these words and these relations, okay? So now the question is, don't die. The question is, how do we single out R2? As the only geometry we want to do, what do we need to add as assumptions and axioms? Okay. So the goal is have R2 being the only plane together with all the things we know, scalar product and what we have. Huh? Be the only plane satisfying our sets of axioms. Okay? So, the first sets of axioms we need is called incidence axioms. Just means intersection. And these are axioms about the lines. Okay? So it just says the two things, or three things. Two distinct points. Determine a unique line. Every line contains at least 2 points. And there are 3 points not lying on one line. Okay? These are the 3. That's all. Okay, for incidence. Okay? Now, the question is, can you find me a plane? So 3 points are not lying on it defines a plane. Okay?
Okay, maybe can that plane be this finite set?
Yes, sure.
Okay, I know that.
Yeah, come.
That is the finite exactly set. Just like the piano, there's one curve that has these 3 points, and these are lines and there's a circle here.
Yes.
And this midpoint and this.
Is there a simpler one?
Yes. Yes. I think that's in combinable mathematics.
Yes, that's finite.
Finite.
Fano.
Yes.
Yeah, but there are simpler versions. It's quite complicated. Simpler.
Similar.
Simpler.
Because FPP has something better.
Yes.
Than the third one.
Not FPP, but not.
There's a simpler version of that. So, what is the most trivial example of a plane satisfying all these?
Oh, yeah.
What?
A triangle? Yes, a triangle. Yes.
Exactly. Now, because so they draw lines, but we only have, so actually it's bad to draw it as a line because you would only have 3 points, okay? And you call these 2 points a line, these points a line, and these 2 points a line, okay? So the whole plane consists only about 3 points. Why? Because no axiom says any line needs to have 3 points.
Yes.
It only says 2,
Yes.
right?
FPP is
So that's slightly, so that's why this is not enough, obviously, to specify a 2. Okay. So let's go a little further, and you will see what. Hey, come on. The second set is called ordering. I write down this one and then we stop, okay? Okay, that's all fine. You need to go, right?
您可以继续讲。
我们都非常欢迎您脱堂，您可以把整个晚自习都脱了。我非常喜欢大师课。
对，然后脱，那你再脱1个小时也不是不行。
No.
Yes, yes.
Okay.
然后再脱半个。
Okay.
There's actually 100 minutes left without class.
Okay. So this is the thing that defines betweenness. Okay. So every of these words I wrote down, betweenness, containment, and congruence, will have its own category. Okay? No. Just number, okay? Just a number. A Roman number for it. Okay. If you want to learn category theory, I'm the wrong person, for sure. So we want to define in-betweenness, yeah? So if I have a point lying between 2 points, A and C,
Okay.
also 2 other points, then B lies between C and A. Reflectivity, whatever. Reflexive. It's reflexive. Okay. And if B lies in between these, we have a line containing all of them. Okay? Betweenness does only make sense if A, B, C lies on the line. Okay? So otherwise, it doesn't make sense. Okay? That's what it says. And now with that one, we can define what a segment is. Okay? So the piece of the line between A and C. Okay, only this piece. How to define it? Can someone tell me?
It has different defined on
Just-
the different metric.
就找两个点，然后那两个点。
Yeah. A segment A, B. I write it this way.
Okay.
How would you define a segment?
Maybe. I don't know. Because we just think about functional method. I think you need to give out metric.
No. You don't need any metric, just with what is on the blackboard.
Maybe this is something of what the set and
Can you write down?
contains
All points between A and B.
Yeah? Okay. Well, then exactly. So the segment,
what the definition of between.
Yeah.
we just say,
它只是一个系，
yeah?
只是一个关系而已。
Right.
Yes, we will write it later, yeah? Because we just say there exists such a relation, possibly. Okay? The plane, which is a set of all points we consider at all, yeah? Where B is between A and C. Okay. And then we just write
Oh wait, I think that's AC, not AB.
yeah.
Segment AC.
It's nicer to have ABC here instead of whatever. Okay. Second, again, AC 2 points. Then exists a B on the line defined by these 2 points such that, I should have, AB 2 points, C on the next, so this is AB, such that C is, no, B between, no, I don't want it to, yeah, exactly, AC. Huh? 3. Any 3 points, only one of those holds. Either I know that A is between B and C, or B is between A and C, or C is between B and A. No? Only one of those can hold, which makes sense. And the fourth one is actually something that's kind of weird. Okay? Weird. And then you can think about why it's necessary. And then we stop here. And it's originally not from Hilbert, because that was discovered by someone else. Originally, Hilbert had something else, okay? And it was proven to be redundant. And this one is Pasch, Moritz Pasch. So it's, okay? It says if I have a triangle or 3 points and a line, okay? Then A, B, C. If the intersection of my line, or not intersection,
F 穿进去了，那么 F，
if there exists a point,
那么 L 一定穿出来。如果直线穿进去了，那么它一定穿出来。
exactly. So it exists a point, that give me a name, D, with in AC, with D in L. Then there exists a point E in BC or in AB with, okay? So that's Pasch's theorem or Pasch's axiom, depending on how you want to define your axioms. Now the question is, why is this necessary? Because that's a weird one. Yeah? It's a weird one. Why would you need? Because there is no reason for the geometry from the first side, at least. Okay? And that's maybe homework for next time. Okay? So the plan for next time, we will finish this one. We will have a little bit of exercise on these, and then we go for curves. Okay? Curves. And then surfaces. Okay. Well, surface is a manifold. It's a two-dimensional manifold, yeah. And when you can do 2 dimensions, you can do any dimensions.
Yeah.
It's the same.
But actually, in the geometry topology, 4-dimensional manifolds are the same as 3-dimensional.
Yes, but you can do this. The definition are the same.
Yes, definitely. Oh, it's red now.
Okay. Any questions? No. Is all good?
Yeah.
All good? Perfect. So next Friday and roughly around the same length. And if you have wishes, what you want to do, okay, you can tell me. Okay? If you want to have, you can clap if you want, but you can, I think it's over. You can go home now. No? It's weekend? Isn't it weekend?
老师，我们还有自习。
Oh, okay.
I really want the class to be longer.
Thank you. But we have next week as well. And we have 15 weeks to go.
My wish
14.
My wish is to make the class longer.
Thank you so much. But we have 14 weeks to go. And hopefully we can do some discrete differential geometry, which means actually that we can, actually I wanted to do that because you can program 3D video games, but if you're not interested in video games, we just do 3D modeling. Okay.
It's boring. Yeah.
Well, it has interesting structure if you like to. You know, things are, whenever you consider something that is super general, like if you want to prove something for n-dimensional manifolds, for any n, okay? Then nothing can really be, not that much can be true for everything. Yeah, if you make it like, what is true for every human being in the world is not that much. If you want to study something about one specific human being, then it might be more interesting because you can have more characteristic. So it's not true that the most general thing is the most interesting one necessarily. Okay? Okay, see you next week.